Hi everyone, how are you doing? This is Lakshmikant Tiwari from KGP Talkie. In today's lesson, we are going to compare Qwen 3.8 with the Qwen 3.6 and also with the Qwen 3.5. So in last 6 months, Alibaba Group released 4 different variant of a Qwen model. They first released Qwen 3.6. In fact, before that, they released Qwen 3.5. Thereafter, they released Qwen 3.6. Thereafter, they released Qwen 3.7, and then they finally released Qwen 3.8 in the first week of the August. But do you really know what they are actually changing model over model? Is there any architectural change at all, or there is just going to be a post-training benefit or post-training improvement? So that is something which we are going to cover in this particular lesson. We will be deep diving inside the architectural differences of a various Qwen model, and then we will be seeing how they improved their performance. What was the actual reason over the performance improvement? Now let me quickly tell you my setup which I used for this performance measurement. So first of all, I used my RTX 5090 GPU with the Ollama, and here is the Ollama version. As you know, RTX 5090 have a 32 GB of VRAM and maximum power is capped here at a 600 watt. I am telling you this configuration so that if you want to recreate this benchmark, you can also do that. And I used here Windows 11 with this Ollama version, and quantized 4-bit version was used here. Whatever this version, the by default comes in from the Ollama. So that is something which I downloaded directly from the Ollama. Thereafter, you will notice I actually ran a huge number of the tasks. Overall, 397 measured generation were done to compare all these models. Okay, this is literally huge. This is literally huge. Okay, cool. Apart from that, one more thing you will notice as we move ahead, you will notice here there is a speculative decoding. So this is something which is mentioned in all models. Qwen 3.5, Qwen 3.6 and Qwen 3.8. We will also discuss here how this speculative decoding is actually going to improve the overall performance. Okay, now having said that, let's go ahead and see what are the architectural differences between the Qwen 3.5, Qwen 3.6 and Qwen 3.8. Okay, so the first of all, let me tell you here that you should not be surprised here to understand, to know here, there is no architectural difference between all these models. They are almost exactly the same model. That means since last 6 to 7 months, Alibaba Group has been working on a same architecture. Now the question comes here, then how the improvement is coming over? Don't worry about that. As we move ahead in this particular lesson, you will also understand how the improvement is coming. But let me first tell you here the architecture. Okay, so we have here the 3 architecture for Qwen 3.5, Qwen 3.6 and 3.8. You will notice here 64 layers are there for all these. Hidden size is going to be exactly the same, no difference in that. Attention heads are going to be exactly the same. Linear full attention is same, vocabulary is same, overall parameter is same, tensor list is also same. This is something which is different. Okay, apart from that, you will also notice here some bold color. So you might ask here question, then what are these things? Okay, so see what happened actually in Qwen 3.8. They have included one additional layer. That's the only improvement. That's all. At least what I see in their architecture, that they added this MTP layer inside the Qwen 3.8. Although later on we will see here this MTP layer was already present in Qwen 3.5 and Qwen 3.6, but they were not utilized. But here in Qwen 3.8, they are actually utilized. Apart from that, you will notice these models, which you will notice here, the total number of parameter, they had this, the image one, basically, they had this image and plus text, the parameters together. But what happened in Qwen 3.8 case, they actually broken down into the 2 part here. So this becomes the image one, basically that is the, the vision one, and this one is actually for the text one. All right, so that's the only difference. Since they had actually, they had splitted this one, so there is a different split for the vision weight. Because of that, you will notice there is a little bit difference in the tensor list as well. So overall, there is two difference, a minor difference I will say here, but a great improvement. So two minor difference on Qwen 3.8 is the additional MTP layer, and then they had separated this vision encoder part from the overall weight. That is the only difference. Okay, cool. So now I hope you have understood here how overall, architectural variations have been there over the different models of the Qwen. Let's go ahead and see how performance improved over the period. Okay. So first of all, you will notice when Qwen 3.5 came in February 2026, at that time, they had live code bench and, the GPQ diamond reasoning somewhere between 80 to 85. And by the time they, the reach here Qwen 3.8, their, overall performance are like 90%. Okay. So the overall gain you will notice here like 10 to 12% only. Okay. This is just a linear gain. Apart from that, you will again here notice SWE Bench Pro. All right. So this is like coding part here. So in the coding part, you will see here a little bit better improvement. So initially it was like a 51%. They reached here a 61%. So it is like a 20%. But if you notice this one, this is a huge. All right. So this is like a non-linear kind of. Okay. So this one is huge. They were sitting around the 41%. But now they are sitting here at 73%. This is a huge improvement. Okay. So you need to, to put your attention on this particular part, agentic terminal. Okay. That means Qwen 3.8 is really doing good in the agentic coding. All right. So in the agentic coding part, it is really good. Now, if question comes here if question comes here related to the agentic coding, that means this particular model is really good in the tool calling. All right. Tool calling and plus decision making. All right. So this is really good in tool calling and the decision making. Remember these two phrases, tool calling and decision making. If I say the decision making, that means it is fast to respond. It is it is trained to take the decision fast. Whereas you will notice later on in this particular lesson, I'll show you, they are not that much, the good decision maker. They keep thinking, and they are not able to make a good decision. Whereas Qwen 3.8 is able to make a quick and good decision. Okay, cool. Now the question comes here that how I have verified all these, whatever I'm currently saying here, how I have verified this. Okay, so I have verified it using 12 verified problem statement. All right. So they are, these problems are coming from the math, reasoning, coding, and so on. Thereafter, I've also taken very hard problem as well. And they are deterministic problem. So deterministic problem means answer is fixed there. Okay. So it's, for example, let's say if some code need to be executed and for a particular input, for a particular given input, output is fixed. Similarly, for math question as well, output is fixed. So I have taken 12 problem statement and their final output is fixed there. So which is known in my script, but that is not known by the model itself. Once model generates the output, then I compare the output of the model and the known answer of my problem statements, and then I decide whether it is correct or wrong and how much it is wrong. Okay, cool. Now the question comes here that, as I told you earlier, that Qwen 3.8 is good decision maker. Okay, so they are really good decision maker. That means they are not thinking much to take the decision. You will notice here for a particular problem statement, to solve a particular problem statement, Qwen took almost 1K tokens only. Okay, and for hard problem, they took like 2000 token only. Whereas you will notice Qwen 3.5 and Qwen 3.6 really wasted like 7,000 to 5,000 tokens. This is like 5 to 7 times more token. Similarly, on hard problem, you are noticing here again 6 to 7 times or 5 to 7 times more number of token. So you can understand here, if they are taking more number of token, that means they are going to actually take more time and also they are going to be the costly. Okay. So that is why I said here these model which you are currently seeing here, they are not good decision maker. Okay, not good decision maker, not good decision maker. Okay, so if a particular model is not good in taking decision, that means they are not good in the tool calling. That is why you will notice Qwen 3.8 really performed excellent in the agentic coding. Agentic coding means it need to take the decision. It need to call a tool, because in the agent itself, you might have heard about the React agent. All right. So, oops, sorry. React agent. All right. So React agent is like reason and then take the action. So for taking the action, it need to call a tool. Okay. So tool is the integrated part of the agent. Okay. Now let's go ahead and see the timing as well. So for a problem statement, which I had given to these model on average, I'm saying here on average. So on average, Qwen 3.5 took like a 23 minute. Qwen 3.6 also took 23 minutes, whereas Qwen 3. Was super fast and it took here 3.5 minutes here. Okay, so now the question comes here, like what are the reason? One reason we have already seen, the token reason. All right, so it was taking like 1 to 2k token only, whereas they were taking like 5 to 14k token. That means number of tokens are high here. Apart from that, what are other differences? Okay, so what are other differences? Other differences we have here, that is related to the speed as well. Later on we will see the speed of Qwen 3.8 is really huge as compared to these model, and that speed is coming because of the MTP. I'll show you later on. And if you have watched my previous videos, there I have really explained this MTP part in so detail that you must have understood that how actually MTP work. Okay, and if you don't know, the link for that video is also given in the video description. You can watch that video and then you can understand how MTP work. Okay, how MTP works in Qwen 3.8. Okay, cool. And by the time, by the way, if you are having any doubt, any question while I'm going through with this particular, the tutorial, let me know in the comment box. I read each and every comment and I reply to each of them. I will definitely, reply to your doubt or your comment. Okay, now the another important finding which I got while testing these three models, that how accurate or how meaningful their reasoning have been here. For example, let me ask here a question. There is two person, all right? Let's say there are two person. So one person, both of them are giving a good answer to you. Basically, both of them are giving you the correct answer. But one person is thinking too much. Basically, you ask a question today and he is answering tomorrow, and the another person is answering your question immediately, instantly. All right. So who is going to be your preference? Obviously, the person who is answering you immediately. Similarly, you will notice here. So Qwen 3.8, we have already seen it was taking like 3.5 minutes only. They were taking like 23 minutes. So it was huge. Now the question here, why they were taking this much of the time? We already knew that they were taking time because their total reasoning tokens were like 5 to 10k, and I guess it was 14k, probably more than that. So 5 to 14k tokens. This was a huge. Now question is here, why they were taking these many tokens? So the one understanding we have already established here, they are not good in decision making. So here is the verification. So you will notice here, I have verified that why they are not good in the decision making. So while I was going through with their reasoning text data, I saw Qwen 3.5 actually got the result in the first half of the reasoning itself. Basically, when Qwen was at the 12% of its total reasoning at that time, Qwen 3.5 had the result. Even after that, it kept thinking. Basically, re-reason, rethink again and again and again, even though it had the answer. For example, let's say if I say it took like 7k token, then I can say here within the 1k token, within the 1k token, this Qwen 3.5 had the answer. Similarly, Qwen 3.6, within the 60% of all traces, they got the answer. Okay. So you can understand here why they are not good in the decision making. So although they got the answer in the reasoning, they could not make the decision. Because of that, they kept thinking. Whereas Qwen 3.8 is good in the decision making. So although they got the answer here by the time they reached the 50% of the total consumed token, but the next 50% what you see here, they actually use this to re-verify. All right, so it was for re-verification, and which is actually the good. All right, so Qwen 3.8 got the answer by the time it reaches the 50% of the token, and then next 51% it used to re-verify its reasoning whether it is correct or not. Ideally it should be something like this. It shouldn't be like this where you have got the correct answer within the 10% of total token, and then the remaining 80 to 90% is being consumed only rethinking. The remaining 80 to 90% is being consumed over the rethinking only. Okay, cool. And I hope now you have understood. Now let's go ahead and see how you can select the reasoning effort in the Ollama. So this is important part actually I wanted to share here. So Ollama actually does not offer currently, the reasoning effort level. You can select the reasoning effort level with the LM Studio. So if you are using the LM Studio, then you can select the reasoning effort properly. Otherwise, if you are using the Ollama, then the reasoning level cannot be selected. I just want to tell you here how many kind of reasoning levels we have here in the Qwen model. You have reasoning level low, medium, high, and X high. So basically that is the max one. All right, so here X high. So the one thing you will notice here, if we do something like this in the Ollama, overall it is not going to affect the reasoning level at all. While I was doing this benchmarking, I also noticed a lot of other differences which I wanted to share with you. For example, you might have heard about the various token generation speed from a different people. So now the question is here, how these variations are coming in a token generation on the same hardware and with the same setup. Actually, it is because of the content itself. So let me tell you here. If you have been following my previous videos, you might have noticed that I reported first 171 token per second speed on August 14 report, and then 125 token per second on August 16, and then 104 token per second speed, and thereafter you will notice here this is going to be the base speed. Now the question is here, why overall this speed is going to be changed here as the time is going over? Why this speed is actually the decreasing? So it is not because of the time, as we are testing over the period of time. It is not because of that this speed is going down actually. So there is a different reason which I wanted to share with you. The reason is actually the type of content we are using. And this is literally a huge finding by me. Generally, the people don't report that why they are getting that particular token speed. So if you are just seeing somewhere token per second speed, then I would suggest you do not trust that speed unless and until you find out on which particular task that token speed is coming. For example, when I tested my the model, especially the Qwen 3.8 actually I'm talking about here, because Qwen 3.6 and Qwen 3.5 does not support the speculative decoding one, or does not support the MTP. Although they have the MTP, but they do not support the MTP. I'll tell you later on what are the problem with them. But as of now, let's understand what is happening with the Qwen 3.8 here. So the Qwen 3.8 have the MTP. Okay, so when I enable the MTP, then I'm getting here 205 token per second when I have given a task of counting only. This is very simple task. And when I gave a task related to the code with the temperature 0.2, I got around 190, and similarly with the temperature 0 for the coding, I got 190 token per second speed. And for JSON data generation, I got 176. But as I move ahead here with the different problem statement where output is not that much predictive, there this token speed, basically the token generation speed is decreasing. Did you notice here the term I used here, output is not that much predictive? Okay, so why I'm saying that? So let me just give you here a sneak peek. Let me just re-explain the MTP actually for you. So what happened with the MTP actually? So let's say this is the overall token currently on which your model is working. Okay, so all these are the token on which your model is working. This is generated, this is generated, this is generated, this is generated, all these are generated, but currently your model is working on this token. Okay, but let's say you have selected the MTP. Okay, so you have selected here the multi-token prediction MTP, a 3 MTP. All right, so 1, 2 and 3, you have got a 3 MTP here, and your model full pass or full model is currently working here. Let's say this is the token which is actually currently getting generated here, and in same time your model is also trying to generate next 3 token as well. So when this next 3 token is going to be correct, when output is more predictive as compared to when output is not that much predictive. Why? Because you see, if you have all these 3 token, so if you want to really select all these 3 token, all these 3 token need to be correct. Only then you can select all these 3 token. Otherwise, whatever the tokens are correct there, only those token will be selected. Only the condition is here, the token correctness should start from the left side. Okay, for example, if this is false, and then if it is true, if this is true, then whole token prediction is going to be discarded, because if first token itself is wrong, then obviously the next token can be wrong. Okay, so everything is going to be discarded. But let's say if you have something like this here, where first token is correct, second token is correct, and third token is wrong, so in that case you can select this token, and model is going to discard this last token. Okay, so what happened if there is a predictive, sequence, their model is able to generate the future tokens while it is generating the current token. That means, for example, let's say counting. So in counting, model knows, okay, 1, 2, 3, 4, 5, 6 and so on is coming. So model knows. Similarly in the coding as well. So let's say if the Python code is being done, then if a Python token has generated def, then now your LLM knows that, okay, after this the function name is going to come here. So it is very much sure that there is a function name, then the parentheses are going to come there, then inside parentheses there are going to be the parameters, and then there is going to be the colon and so on. So they are very much predictive. But if you start writing the essay or the fictional story and so, then output sequences are not that much predictive. Because of that, MTP actually MTP does not perform as fast as it is performing on the coding part and the counting or the JSON data generation part. Even after that, you will notice this MTP is giving us the faster response as compared to the base one. So the base token speed which you are currently seeing here, that's the 79 or 80. This 79, 80 is coming when MTP is off. That means when multi-token prediction is not used, then general speed is coming like 80 token per second. Okay, cool. So if you use the MTP, even in worst case scenario, it is giving you almost how much? 10% of the improvement. But for other tasks like code generation, JSON data or essay, it is giving sometimes like more than 2 times of the improvement. So overall, what you need to take from here, from this particular lesson or from this particular explanation, that token speed is not just dependent on the model. Token generation speed is dependent on the type of the content you are generating. One more thing I want to tell you here, as I have been telling you earlier, this the speculative decoding have been the part of the Qwen 3.5 and Qwen 3.6 models as well. So why Ollama or why Qwen never utilized this speculative decoding in these models? Actually, what happened, if you enable the speculative decoding in these model and you try to generate the essay or surreal, the fictional story, then you will notice Qwen 3.5 and Qwen 3.6 really starts performing below the baseline. That means if you don't have MTP at all, it is doing much better than having the MTP. Okay, so as we had seen here in this particular diagram, as we are moving here toward those stories which cannot be predicted, then in that case overall speed is going to be decreased. Because of that, they never used this MTP Qwen 3.5 and Qwen 3.6. They use this MTP only in Qwen 3.8. So you will notice here Qwen 3.8, Qwen 3.8 generation speed is really very high. And that thing is coming from the draft acceptance rate. Again, I'm telling you, MTP is something which I have covered in my previous videos. Go ahead and watch that on my, on my YouTube channel here. So I selected this Qwen 3.8 is there. Let me just quickly show you here. So you just need to come here inside the videos, and there I have here the Qwen 3.8. So this is where I have explained here the MTP, KV cache and flash attention. Everything is explained here in detail. You can watch and you can understand how actually MTP works. Okay, having said that, one more finding I wanted to share with you related to the context window as well. And this finding is also very important. Okay, let me just show you here the context window one. Actually, this diagram which you are seeing here, this is again related to the MTP part, which I just explained you. So in the context part, I wanted to share here one thing. For example, our model have overall the context 264K token. All right, so this is the overall context which our model have. Question comes here, you might have heard so many times that how much context window you are using. So can you utilize this whole context window or not? Again, if you have watched my previous videos, then you can definitely answer it immediately. Otherwise, let me explain you. So you can use the overall context window. There is not much of problem nowadays, but if it is empty, then it is okay. But if you fill the context window, then it creates problem here. Okay, why? So if you fill your context window, let's say this is your context. If your context is increasing, then your KV cache, let's say if this is your KV cache, okay. So if this is KV cache, generally KV cache is, KV cache is stored in floating point 16-bit. Okay, so KV cache increases. So if KV cache increases, that means speed is going to be decreased. And again, as you know, the context increases, then model performance also decreases. So if this is a performance, if I say here, this is going to be the performance, then performance is going to be down here. Okay, so you will notice here one thing. As context, I'm talking about here the context filled. I'm not just talking about the overall context window. So this much of the context is already filled. That part I'm saying. Out of 264,000 context window, I filled 16K token. Then I got a speed of 70K. Okay, without MTP. Then what I did here, I filled 48,000 tokens in the context window. Then my speed got decreased here to the 65 token per second or even lesser than that. Then again, I filled 80,000 token, and then finally my token generation speed got below the 60 token per second. And it is not just happening for one model. It is happening for all model, and consistently. You will notice here in same manner it is actually happening for all model, and it is happening consistently. Similarly, this is the generation speed. Similarly, you will notice here prompt reading speed. All right, so this is known as a prefill token actually. So whatever input goes inside the model, all right, so that is actually the prompt reading speed. Prompt reading speed also got decreased here. Initially, it was 3340, basically 3340 initially for all models almost. Thereafter, when 80,000 tokens got filled here, its overall speed got decreased to the 2300 only. So this is literally huge understanding here. So if someone asks you what happened if you fill the context window of a particular model, then you can answer it. So what happened? If you fill the context window, then the KV cache increases. If KV cache increases, then the time to first token also increases. Apart from the token generation speed also increases, and also the performance decreases as well. As the context window is filled there, then your model starts hallucinating because there is too much information already present in its context window. That is why it is always recommended to reduce the used context. If you have used the cloud code, then you might already know that there is command known as the compact. You use this command to summarize your conversation, so that if you have a very large conversation, then that conversation can be summarized in a few tokens, maybe 10,000 tokens or so only. Okay, great. Now I hope you have understood properly. Now I have not specifically answered from where the performance improvement is coming. Now let me answer you as per my own understanding. So one thing I see here on Qwen 3.8, apart from the MTP, I don't see there is much of the architectural improvement over this model. So I see the token speed is coming from the MTP itself. And apart from that, on the accuracy performance part, I will say that that improvement is coming from the post training. So what is the post training? Post training is like if model has been released by Alibaba, then they just don't stop the training on that particular model. They just keep training behind the scene. All right. So just keep training, and model performance keeps improving. Once model performance improves, then they finally release it with the next version as a next version. Now they can do, I'm not sure whether they have done the incremental architectural changes. They might have done actually. So that is something which I could not see in gguf file, but overall I understand they might have done the architectural changes. The other thing I feel here that for a better improvement, actually, during the post training you need the better data, so quality data actually. So what I feel here, apart from multiple iterations of the post training, they have also used here the quality data as well. So again, if you have a good quality data for the fine tuning, obviously your model is going to perform better. Okay, cool. Apart from that, I have here a little bit more detail which you can which you can read and go ahead after once I finish this particular video lesson. And link of this article which you are currently seeing here, this is given in the video description. And I see a lot of you have been liking my technique of explaining these models recently, and I really appreciate to all of you who have watched my videos and who have commented. Please do not forget to like this video as well and leave a comment here as well, and also subscribe it. And if you really find this particular lesson useful and helpful, please do not forget to share it on social media like LinkedIn, Twitter, and so on. And also please don't forget to tag me there. All right, everyone. Bye bye. Take care.